Welcome, everybody. Welcome back, or welcome staying here. Welcome to the Enhancing Clinical Practice and Outcomes stream of the SNOMED CT Expo 2024. My name is Rory Davidson. I'm the Chief Digital Information Officer at SNOMED International, and I'll be moderating today's session. All the questions will be answered at the end of the presentation. Online attendees, please use the Q&A to ask any questions. And in the room, once we've finished, please raise your hand and we'll give you a microphone. I'm now very, very pleased to introduce that Tangchitnob, hopefully I got your name, from the Ramathibodi University of Thailand, who will be presenting healthcare information extracting using LLMs and SNOMED CT, sharing Thailand experiences and challenges. Over to you.
Hi, my name is Nat Tangchitnob. I'm from Thailand, and I'd like to share our experience using the LLMs to extract health information. Okay. Oh, it's now. Okay. In the last session, we hear about how MedCat extracting information from the data, and it's open source. Everyone can use it, but not Thailand, because our data looks like this. We have like Thai language and English language, like jumbled up together. And even though MedCat is like a free software and it's very good at doing its job, but in the behind technology, it uses bird. Exactly, it's a biomedical bird, which don't have Thai embeddings. So here we see the potential of large language models, which it can like translate Thai into English and even do something else like giving diagnosis of the patients, and it gives like a long list of possible diagnosis. So we think why we don't use it to extract information from our Thai medical records. So we think we should have a prompt and input text, and the output is going to be concept and SNOMED CT IDs and a lot of stuff, SNOMED stuff. So we tried. First, we developed the prompt, which we follow the kind of current best practice. We have a context, the task of what we want it to do, and then we provide the examples, and then we put in the input medical notes. So let's see how it works. First, this one is the output of the GPT-4o, and the other one is GPT-4o mini. So the clinical terms they extract is kind of similar, but the problem is with the SNOMED CT IDs. The GPT-4o like extract about 50% right, but the mini ones, just one is right. But we think it's have a lot of SNOMED CT knowledge, because if you look at the ID, they have a namespace identifier, partition identifier, and check digits are almost right. So we think that it has some of the SNOMED CT knowledge, but it has a problem which we call hallucination. It can be because it has limit input length and also the standard prompt. Or also, it can have this problem because it lacks the up-to-date information. So how do we fix it? First, maybe we can develop a better prompt. Second, we fine-tune the models. The third one, we can do RAG. So we try to do the third one first, because we think it is going to solve this problem. So what is RAG? It's the Retrieval Augmented Generation. So from the workflow, we just put the external database into the large language model, so it can retrieve information from the database and then augment the prompt and generate the answer that we desired. So we use the same prompt and we extract clinical terms, and then we construct a database made from SNOMED CT, which on your left side is the SNOMED CT ID and there's fully specified name. Then we use the encoder to construct the vector representation of the fully specified name and then put in the vector database, like here. And then we have the query, which here we use. I will provide an example of tachycardia. We encoded the tachycardia from the query and then we compare with the information in the vector database. So this is our actual output from tachycardia term. We first select the nearest of the term. For this one is 25 top nearest terms. I don't know if it's too small, but the tachycardia one in the first 25 terms is on the ninth top term. See, because in SNOMED CT, tachycardia is kind of common terms. We have a lot of tachycardia in the fully specified names. And here in the RAG models, what we want is tachycardia, which is in the finding. So we use another model to re-rank it. And then we use another prompt to let the model choose which one is the best. So the re-rank one, tachycardia come first, see, and then the final answer is the tachycardia one. So let's do it with our data. We use the data that is manually extracted and mapped to the SNOMED CT. And then we select the most common 30 phases to use it in this study. So it's like this. We have about 195 terms, which 100 terms is English and another 95 terms is Thai. So we also include some of the partially mapped terms and also abbreviation for English and Thai abbreviations. So let's look at the result. So we have the fully mapped terms mapped to the same SNOMED CT ID. Out of 63, it's 36, which is the 57% exact mapped. And then for the partially mapped, its performance is almost similar to the fully mapped. And with the abbreviation, we didn't provide any context. It only have 20% accuracy. And then for the Thai terms, the fully mapped one, it's 30% accuracy, and the partial one is even lower. It's detect just like 2 out of 18, and the abbreviation is the worst. They didn't extract anything. So overall, it's 37.4% accuracy. So we do another more in-depth analysis. We want to know if the extracted SNOMED CT IDs and the extracted FSN is correct or not. So out of 195, 39, which is 20%, extract wrong SNOMED CT ID or fully specified name. The reason for the wrong extraction is first, there is a spelling or grammar wrong. Like the actual FSN is the bacterial sepsis, but the model extract as a bacterial septicemia or acute suppurative arthritis caused by bacteria. It extract acute suppurative arthritis due to bacteria, which is like naming convention of SNOMED CT. Next is the extra information. Sometimes the model is not like fully understand or fully sure about the answer. So it output some of the kind of explanation too. And then some of the extracted fully specified name lost some of the information, like structure of muscle tissue, they extract just the muscle tissue. Or the bedridden, they extract just bed and they leave the others. Then the wrong semantic tag, sometimes it's like the SNOMED CT ID that they extract is the situation, they actually extract it as a findings or generate some wrong SNOMED CT ID, like this one, this booster, the immunization. The actual one is they have like 2 digits wrong. And the last one, no SNOMED CT ID and FSN, which is about 5 instances of this. So the overall discussion, the overall accuracy is about 37%, which maybe because of the English term accuracy is higher, but Thai term accuracy is about one quarter or 26%, and it's even lower in the abbreviations. I think from what I inspect in the wrong extracted SNOMED CT ID, I think it's kind of like more like human mapping error. Like some extract like similar terms in a different hierarchy, like findings and disorder or procedure and findings, something like that. And also, I think maybe the local terminology is not really aligned with SNOMED CT that much. We have a local terms and we have a local understanding of what should be the terms, but it is not aligned with the SNOMED CT conventions. And the last one I think we should use to improve our models. Here we use just a vector-based matching through the embeddings. But maybe in the future, we should use a little more of what SNOMED CT can offer, like the structures of SNOMED CT, the ontological structure, which can be used coupled with the graph database or something like that. Or in this study, we just use the FSN. We didn't include the synonyms or the description of the SNOMED CT. So I think if we include that, it could like better our result. So I'll just like a little comparison with the earlier this year, we have a competition which called SNOMED CT Entity Linking Challenge, which they adopt a lot of what we are trying to do. First, they have a lot more synonyms, not just from the SNOMED CT. They have include some of the OMOP terms, and then also do the fine tuning of the LLMs, and also they use RAG just like we used. And the winning team, they use the dictionary-based approach. Didn't use LLM at all. We tried, but it took a lot more human effort to build dictionary-based to build a dictionary. So this one they used an OMOP, which kind of like a database, big database of a lot of terminologies. The second one they used the ensemble bird-based model, which a little challenging for us as well because in Thai we have Thai birds, but we don't have Thai medical birds, and also we have medical bird, which is in English, but no Thai embeddings. So if we are going to use bird model, we have to train it from the scratch, which is going to be very expensive and time consuming and resource consuming due to the limited resources of both financial and data limited resource. We came up with the third one, we used RAG, but we didn't fine tune it. But we are going to. And the database, they use Fierce Vector database, which kind of similar to ours. And also they use the All-Mini LM L20 as encoders. We use the multi-language B5 encoder. Yeah. So the conclusions and future direction. First, we think the modern LLMs can process Thai text and maybe limited capabilities of medical context, but possibly in the future they can. And then with RAG, it improved the mapping performance of LLMs from the first one. We have like 1 out of 8 correct, then it became like half of it is correct for the ChatGPT 4 or mini. And then we need a little more systematic evaluation. If you notice, we use the terms from human curated text, Thai text, but we didn't use the model on the original text, longer text. So I think maybe the evaluation should be a little comprehensive if we have the data for doing the evaluation. So here I would like to maybe like advocate for SNOMED CT to share how their constructed data for doing the SNOMED entity linking challenge, which is going to be very helpful for us to construct a data in a Thai context. And also, maybe we have to do a lot of more prompting strategy and also the try other models like a relanguage models or base model, which is maybe the open source one. And also, I'd like to advocate for growing communication and also collaborations with other countries, especially the Asian countries. We should like do it together and grow together. So that's all for my presentation.
Thank you very much, Nat. Fascinating. I've got lots of questions, but I'm moderating, so I can't ask. So any questions? We'll take questions from the room. If you're online, please add questions to the Q&A. Raise your hand if you'd like to ask a question. Well, I'll just get mine, and so this is the opportunity. Okay, thank you. So, yeah, fascinating presentation. As you said, one of the challenges with large language models is languages, other languages. We've done stuff using the Aya model from Cohere.ai, which is a multilingual language model. Yeah. What other language models have you investigated? You mentioned GPT.
Yes, we investigated Claude models and some of the commercial stuff, but we didn't have the like computational resources to do the open source one yet. But we are trying to expand our financial funding here. So that's all for now. Yeah.
I don't know that question is addressed to Nat or to Rory, but I'm from Thailand. I'm Dr. Bunchai from Thailand. I'm working with Dr. Nat on this project too. I think the SNOMED CT also providing some kind of the translation tools and the simplicity, something like that. How well the country can benefit from those kind of the challenge that we are facing now. Our aim is that if we can get the medical record, at least learning about the Thai context, language that clinician use, and then helping to map into SNOMED CT. That would help a lot on our side to persuade the clinician to adopt and then develop the using SNOMED CT in the electronic medical record. So it's more on Rory than not, right?
We take these questions offline. I can answer all, and there's lots to be done in this area. So, questions for Dr. Nat?
I'm Dr. Lee from Taiwan. We have almost the same surrounding atmosphere, but when we do non-electronic traditional medical recording, English is the most useful. But I think the same as non-English using territory, there's a lot of abbreviation which is not formal or another short of grammar, not so grammar correct. And so I think natural language processing is the best way for solving the problem, even different language. So I feel happy because mostly we use English as a writing language. But my response is, if it is possible, other than the SNOMED CT, you can use another more traditional but still linking to SNOMED CT, which is ICPC, International Classification of Primary Care. It is a little bit loosened, not so restricted as ICD-10 or ICD system, but it's more like the a general language of especially in the description of the patient behavior. So I never heard about any trial about this. So I think there's two solutions. One is to use another kind of generative AI tools other than the current generative general generative AI, something like the ChatGPT 4.0 or BERT, or we can develop another, but with narrow scope. And maybe we can use something like the existed ICPC3. The terminology has been standardized and maybe coupling or linking together with the SNOMED CT. I think, I don't know, is it possible? I'm a freshman, so I'd like to know your opinion. Thank you.
I think for me, I think it is possible. Yeah, but ICPC, I'm not sure about it. I mean, I do still think SNOMED CT is more detailed than ICPC. Yeah.
Thailand, we don't coding in the ICPC. ICPC, International Classification of Primary Care. Sometimes we consider about this, and then at first we would like to map the ICD to the ICPC. I know that the granularity in the ICPC is quite not much. SNOMED is 360,000 concept, but ICPC maybe 400, 500, something like that. The unfortunate is that we don't encode our medical record with the ICPC. That's why we don't have those in our Thai medical record environment. What we have now is free text and ICD.
Sorry, sometimes the question is, we used to the granularities to find. So when you use it to processing the very, very coarse writing from the physician, from the practitioner, the error percentage will be increasing. So it becoming annoying, and to increase the difficulty of development. So sometimes we add on some medium-sized granulation, granular size. Maybe they will make peaceful, and then make the progress will be more smooth. And I think, I don't know if by the advantage of AI, maybe the ICPC or any other coding system is not absolutely necessary be implemented before or implemented over the medical record system. It can be as a tool of processing. I mean, something like the old ICD version or another classification system. Sorry.
Yeah, there's a lot of discussion. I mean, the LLMs, we can go on forever, but I'm very aware of time. So I think we'll pose the questions for now. Thank you very much. That was fascinating. Mother, thank you.